Hello everyone, good morning. I hope everyone is good. And today we are going to start with the very first chapter. And in this chapter, we will be reading first charging methods and Coulomb's law. Okay? So we have to, like yesterday, I discussed a lot of things. So we have to be in always high energy and with positivity. Yes, from each and every class, we have to pick whatever is getting taught and we have to stick to homeworks and whatever suggestions is being given. Okay, so I hope आप लोग चीजों को follow करोगे. Done. Sorry. So let's first see what we are going to read. So if you will go through your NCERT, so the electrostatics basically covers two chapters. Done, first and second one. So basically in first chapter, we read about charges and electric field, and in second chapter we discuss largely potential and potential energy. Okay, so this P22 topic code will cover your first chapter of your NCERT. Okay, so in that thing, what things we are going to read? तो सबसे पहले हम लोग पढ़ेंगे कि what are different kinds of charges and what are their properties. Okay, and after that we will look into what forces acts between two or multiple charges. Done. Then we will see if there is a charge in a region, what exists in that space, what else exists in that space. That basically we will call electric field later. Okay, so electric field पढ़ेंगे. उसके बाद we will learn a law, that is your Gauss's law and its application. This will basically facilitate us in calculating electric field values for complex systems. ठीक है, तो वो हम पढ़ेंगे तो समझ में आ जाएगा क्या है. ठीक है, and in the last we will read electric dipole and electric field because of it. Dipole, you must be aware of it in chemistry. Dipole क्या होता है? Two equal and opposite charges separated by very small separation. तो ये आपने पढ़ा होगा. So we will largely discuss here this thing. ठीक है? So आज की क्लास में what things we are going to discuss? We are going to discuss first two things. First two things, if I say, then I will be discussing these two, charges and electric force. ठीक है? तो चलो देखते हैं फटाफट. Now under charges, what we are going to read? We are going to read types of charges, ठीक है? Properties of charges, and then we will see how we can charge bodies. If I have a neutral body, this neutral body can be conductor, insulator, and if I have to charge this body, how I can do. Okay, so under this we will cover this. Okay, so let's first go through these three things, and in between, if anyone is getting any doubt, you can write to me in the chat box or you can raise your hand. I will be addressing your problems. ठीक है, तो पूछना मत भूलना, पूछ लेना कुछ भी डाउट हो तो. Now सबसे पहले like basically if we go inside nucleus, we get three subatomic particles, है ना? Proton, neutron, electron. Done. So basically there are two types of charges, positive charge and negative charge. Done. Positive charge, proton, basic positive charge proton carries, and its value is equal to how much? Plus 1.602 into 10 to the power minus 19. You all must be aware of this. Again, electron also carry basic negative charge, that's value is equal to minus 1.602 into 10 to the power minus 19. And inside nucleus, there is one neutral thing, that is neutron. Done. Again, its mass I have written here because ahead we will have use of it also. तो इसको हमने इसलिए यहाँ पे मैंने लिख दिया है. If you see carefully, mass of proton and mass of neutron is almost equal, but they are not exactly equal, but we can approximate them to be equal. तो इसलिए मैंने यहाँ पे equal लिखा है. Later in modern physics, we will study कि what is that small difference in mass between neutron and proton. ठीक है, लेकिन यहाँ पे मुझे उसको discuss करने की जरूरत नहीं है. That's why I have just taken them to be equal. Okay, and if you look at the mass of electron is 9.11 10 to the power minus 31 kg. It means mass of proton is to the order of how much? 10 to the power minus 27 mass of proton, and mass of electron is of the order 10 to the power minus 30. यानी कि proton is how many times heavier? 10 to the power 4 times heavier. than that of electron. So proton is very heavy if we compare its mass with the mass of electron. ठीक है, तो ये चीजें हैं, these are very basic things we need to keep in our head. Now properties of charges. तो आपने पढ़ा होगा in class 10th, like charges repel if there are two positive charges in the vicinity, in the surrounding, then they will repel each other. If there are two negative charges, they will repel each other. If one is positive, another is negative, separated by certain distance, they will attract. These things came from the experiments that scientists performed at various times or years or whatever. ठीक है, तो ये हमें पता है कि like charges repel and opposite charges attract. Now, charges are quantized. What is the meaning of this? Charges are quantized means कि suppose somebody is giving you a body and person is saying कि this body is charged body. ठीक है, so it will have certain amount of charge, right? How much? So that certain amount of charge will always be sometimes charge of electron or charge of proton. यानी कि charge on this body will always be integer times charge of electron or charge of proton. That is Ne. If it is positive, तो plus Ne. If it is negative, then minus Ne. Means charge is always integral multiple of E. This body can have charge 1E, 2E, 3E, always integer times E. Not, we won't say 1.5E. Okay? So quantized means charge will always be the integral multiple of basic charges, that is plus Ne or minus Ne. But there are exceptions again. जैसे there are more subatomic particles getting discovered. जैसे quark होता है, तो quark के पास charge होता है plus 1/3. So these are the exceptions. Okay. चलो, charge is conserved. Charge हमेशा क्या होगा? Conserve होगा. What does it mean? In an isolated system, total charges is always same. Again, charge is conserved, but where? When the system is isolated. Please look here very carefully, ये वाला thing. क्योंकि this thing I will be using very often for solving even complex question very easily. ठीक है? तो जब भी मैं physics पढ़ाऊंगी, I will be using a term that is called keyword. ठीक है? And what are keywords? According to me, keywords will be those words which will help you solve questions easily. And one of my keyword is isolated system. ठीक है, तो इसको तुम लोग मार्क कर लेना. ठीक है, की तुम लोग एक काम करना, at the back of your copy, make one page, give heading keyword और उसके नीचे पहला keyword isolated system लिख के रख देना. ठीक है. Now, what is isolated system? And charge is conserved only when the system is isolated. Matlab, if there is a conductor, suppose, and it has some positive charge, okay? When it will be called isolated if it is not in contact with any other conductor, or even if it is in contact with another conductor. जैसे देख लो, अगर मैं बोलूं कि यहाँ पे एक और कंडक्टर है ऐसा, इस पे भी कुछ चार्ज होगा, सपोज कर लो कुछ ऐसा चार्ज, डन. एंड इफ आई एम सेइंग दे आर फॉर्मिंग अ सिस्टम, जैसे मैकेनिक्स में यू मस्ट हैव स्टडीड हाउ टू आइडेंटिफाई सिस्टम. तो यू कैन कॉल वन बॉडी एज ए सिस्टम, टू बॉडी एज ए सिस्टम, डिपेंड्स ऑन योर कन्वीनियंस. तो मैं कह रही हूँ कि ये दोनों बॉडी क्या है? सिस्टम. डन. सो इफ these two bodies are constituting one system, this system will be isolated only if it is not connected to any batteries or anything else. ठीक है, अगर ये बैटरी से कनेक्टेड नहीं है ये सिस्टम, तो ये क्या होगा? It will be what? Isolated system. Again, just I'm giving you more clarity. कि suppose कर लो here what I'm doing कि I have a sphere, metallic sphere है, इस पे charge positive. ठीक है, मैंने इसको बुलाया isolated system. This is isolated. This is not connected to any battery. So with first loop, we can say that this is isolated system. Now what I am doing, I am connecting this to another metallic sphere. Okay? I have called this as my system. Okay? What I did, I connected it to another metallic sphere. What will happen? This metallic sphere will transfer some of its charge to it. Done. So this system is going to lose its charge to this one. Done. So it will start gaining some charge. Now this system is not isolated. Now it is not isolated because yes, still it is not connected to battery, but it is connected to something that can take charge. Done. So it will lose charge. So its charge will not remain conserved. Charge is conserved when my system is isolated, means it is not connected to any battery or it is not connected to any other body which can take its charge. Then charge will remain conserved. Just if I call these two as a system, then I can say charge is conserved. Because I am considering these two as a system. Whatever charge this body has, suppose Karlo, this body has plus Q charge initially. And what is happening? It is giving its a small Q charge to this. Okay? So how much charge is remaining on this sphere? Q minus Q. But total charge of the system I am taking these two spheres together, I'm taking as a system. So again, initially how much charge was there? Plus Q. Finally, how much charge is there? Again, plus Q. If you're finding it difficult to understand, chalo main fir se samjha deti hu. Just see here, this was the case. This was the case, right? So this was having some plus Q charge. Done. And I called it as a system. If I'm calling it as a system, done. So is this an isolated system or not? So yes, now abhi to ye isolated hai because it's not connected to any battery and also it is not connected to any body which can take its charge. Now what I'm doing, I'm connecting it to another conducting body through conducting wire. Now what will happen? This system, again, still my system is this, but now this system is not isolated because it's connected to something that can take its charge. So suppose Karlo, it is giving its plus small q charge to this one. So how much charge will remain on this sphere? Q minus Q. So yes, this system is not isolated because it's losing its charge. Its charge is not conserved, right? If I consider this two whole sphere as a system, then are they isolated or not? Yes, these two together are isolated. Kyunki whatever charge is going from A sphere is getting stored on B sphere. So overall charge is remaining conserved in this system. Then so these two together will constitute isolated system. But if we consider the single one, this is not isolated. Then so it's very important to understand isolated system. We will be getting its use further ahead. Okay. So chalo, charges are transferable. Yes, we can transfer charge from one body to another. So just now we have seen ki if one has a positive charge and if we are connecting it to another conductor through a conducting wire, what will happen? It will transfer its charge to it. So yes, charges are transferred. Okay. Chalo, method of charging. Let's look at method of charging. Conduction hai, induction hai, by friction. One by one, we will try to understand what is conduction, what is induction, and how we can charge bodies by friction. Till now, anyone has any question? किसी के पास कोई question है? Anyone? कोई question? I'm just waiting for you people. अगर question है तो बता दो. नहीं है, चलो ठीक है. So first I will discuss. एक second, just give me 1 minute. So first I will discuss what charging by friction. So let's see how we can charge bodies by friction and which type of bodies can be charged by friction. चलो मैं एक simple सा example लेती हूँ. An example is what? Suppose I have taken a silk cloth. So this is a silk cloth and I have a rod. मेरा diagram बहुत ही खराब होता है because I am very bad at drawing. ठीक है? This is my silk cloth. ठीक है? And this is my what? This is a plastic rod. Suppose. ठीक है? या फिर कुछ ऐसा करते हैं अभी. To make you better understand, let's take one conductor. Suppose this is a conductor, okay? And another one is what? This is a insulator, okay? You all know a little bit of chemistry, है ना? लिटिल बिट क्या ज्यादा ही पता होगा. सो सपोज करो मैं आई हैव टेकन सच काइंड ऑफ इंसुलेटर विच हैज हाई इलेक्ट्रॉन अफिनिटी. हाई इलेक्ट्रॉन अफिनिटी. ठीक है. So it has high electron affinity and this conductor belongs to S block. So if conductor belongs to S block, if metal belongs to S block, it will have high tendency to lose electron. है ना. इतनी केमिस्ट्री से तुम लोग को पता होगा क्योंकि मुझे भी याद है अभी तक. So this has tendency to lose electron very easily, and since this insulator has high electron affinity, what will happen? It will have tendency to attract electron very easily. Now what we are doing? We are rubbing these two bodies, these two, conductor and insulator. Okay. When we will rub them together, what will happen? Heat will get generated, and because of that energy generation, this conductor will lose its electron. And since this is in contact with the insulator, this insulator has high electron affinity, it will easily catch that electron. So during that rubbing process, what is going to happen? This insulator will get negatively charged and this conductor will get positively charged. Then, so in first look, we can say that both because initially this was neutral, and this was also neutral. Then one was a metal with high tendency to lose electron, other was non-metal with high electron affinity. When we are rubbing them, what is happening? Metal is losing electron and non-metal is gaining that lost electron. Okay. So definitely metal will gain positive charge, non-metal will gain negative charge. That is insulator and this is conductor, right? So this is happening. So in first look, we can see that this neutral body, that is insulator, also got charged, negatively charged, and conductor also got charged, that is positively charged. But it is not possible to charge conductor easily by friction. Why? Because देखो, if you are rubbing it, what is happening? Metal is in your hand and also non-metal is in your hand. So both conductor and insulator is in your hand. We are conducting body, right? And if you are in your laboratory room, अगर मैं यहाँ पे drawing बनाऊँ, बहुत ही बेकार हूँ, बट आई विल ट्राई. तो ये पर्सन है, इसके हाथ में क्या है? इसके हाथ में है ये मेटल. ठीक है. जिसपे कौन सा चार्ज आया? पॉजिटिव. और यहाँ पे तुम्हारे दूसरे हाथ में क्या होगा? अरे रब्बा, मैंने 3 हाथ बना दिए. दूसरे हाथ में क्या होगा? चलो, नॉन मेटल, नेगेटिवली चार्ज. ठीक है. सो दिस इज नॉन मेटल, दिस इज इंसुलेटर. अगेन दिस इज conductor. Why I have drawn it, you will get to understand. Since this is a conductor, we are also a conducting body. I am standing on the ground. This is also a conductor. So conductor, conductor, conductor. This positive charge will get easily nullified. Okay? But since this is an insulator, its negative charge will not get absorbed by earth, but its positive charge will get absorbed by earth. So it will very instantly, it will again become neutral. So it's very hard to charge a conductor by friction, but we can easily charge a insulator by friction. So by friction, we generally charge what kind of body? Insulating bodies. ठीक है. तो यहाँ पे देखो मैंने इसलिए लिखा है, only non-conducting materials can be charged by rubbing with neutral bodies, because if material is conducting and if it is getting charged very within some microsecond, it will transfer its charge to earth. ठीक है. So we can charge conductor by friction only if we can avoid that earthing wala thing. Okay. Chalo, now charging by conduction. How we charge two bodies by conduction? So in conduction method, what happens? We have one neutral conductor, we have another charged conductor, and what happens? We bring in contact these two things. Matlab, I was having one neutral body and another body was what? Charged, negatively charged. And what I am doing, I'm bringing these two in contact. So if these two things are coming in contact, and since these two are conductors, one will transfer its charge to another. So that thing is happening here. And after it is getting charged, we will remove the contact. So we have removed the contact and this body has got charged. So what is happening during this process? These two bodies must be conductor, first thing. Second thing, this body is losing some of its charge to this body. So the body which is used to charge is also losing charge. Okay, so this one will lose the charge. Again, the body, neutral body is getting same nature of charge as this body. And now this body was having negative charge. So neutral body has also got what kind of charge? Negative charge. Okay. So these are the summaries. Both have to be conductors. Contact is required. Yes, both objects acquire the same type of charge. Charging body, lose charge. So this is charging by conduction. Okay. This is a very easy. Now induction. What is happening? In charging by conduction, we are losing some amount of charge of the body used to charge. Done. So if we don't want it to happen, how we can charge a body? So that we can do by induction. Again, induction में कैसे body, जैसे conduction में which kind of body you can charge by the method of conduction? Conductors only, है ना? And through induction also we will see that only we can charge a neutral conducting body through the method of induction. So here I have taken a neutral metallic cylinder. So this is a conductor, this is neutral. We have to charge it. Now we will take one charging body. So which charging body we are taking here? That is ebonite rod. This is an insulator. It has a positive charge. Done. So initially, suppose कर लो, separation between these two is what? Infinity. They are very far away from each other. Not one is influencing other. There is no influence of one on another. Okay. Now first step will be what? First step will be, we will take this ebonite rod close to this neutral metallic cylinder. So that we are going to do. अब देखो यहाँ पे close लेकर गए. Step 1. So if we are bringing it close to this neutral metallic cylinder, what will happen? Since this is a metal, this is a conductor. Conductor की property क्या होती है? Just focus on the property. So conductor is something that has free charges. Done. So what will happen? This conductor has free charges, free positive and negative charge. Suppose it has. So what will happen? What will happen? This positive charge of ebonite rod will attract the negative charge of this conductor. है ना? Negative free charges. है ना? So electron will start getting accumulated here and positive charge will start getting accumulated here because of this ebonite rod coming closer to this metallic cylinder. So this is going to happen. Charge distribution is going to happen in this neutral metallic conductor. Still it is neutral. अभी भी ये क्या है? Neutral है क्योंकि how much negative charge is here? The same amount of positive charge is here. So overall, this negative and positive charge has not left the body. Still it is inside now. So still it is neutral. Only charge distribution has happened. Negative and positive charge has got separated by certain distance. That thing has happened. Okay. Step 2. So charge distribution will look something like this. Now step 2, what we have to do? We have to earth it. Earth it. Again, another keyword. That is your earthing. Earthing को समझना है धीरे धीरे as the class will move ahead. So I have connected this with earth. Earth is what? Just try to understand. Earth is what? Earth is a huge conductor. This is a conductor. Conductor do what? It takes charges. Done. So this is a huge conductor. Earth is a huge conductor. It is connected to something carrying positive charge. So it will take up this positive charge. ठीक है? क्योंकि अर्थ क्या है? हमेशा ही भूखा है. चार्ज के लिए वो हमेशा ही भूखा है. Done. So it will just consume that charge. तो इस positive charge को वो खा जाएगा. So here there won't remain any charge after we are connecting it to earth. ठीक है? हमने earth से इसको connect कर दिया. Now this negative charge earth will not able to eat. उसको नहीं खा पाएगा. क्यों? क्योंकि this negative charge is bonded by this positive charge. This positive charge is attracting this negative charge, and because of this attraction, this is bonded, right? So earth will not be able to attract this negative charge to itself because it is bonded. But this positive charge is not bonded to it. Okay? So this is here. This is coming down. Done. तो क्या कैसा दिखेगा after earthing? Yeah. This charge layer is gone. This charge layer is gone. Now what you have to do? Step 3. First remove earthing. अगर आप पहले एबोनाइट रॉड को रिमूव कर दोगे, व्हाट विल हैपन, दिस नेगेटिव चार्ज विल नो लॉन्गर रिमेन बॉन्डेड एंड दैट विल गो इनटू अर्थ, और अगर ये अर्थ में चला गया तो अगेन दिस विल रिमेन एज न्यूट्रल, ठीक है। डन। सो व्हाट वी हैव टू डू फर्स्ट वी हैव टू रिमूव द अर्थिंग को रिमूव कर दिया। नाउ सिस्टम विल लुक समथिंग लाइक दिस। अब क्या करो, अब आप रॉड को रिमूव कर लो। सो इफ यू आर नाउ रिमूविंग द रॉड, व्हाट विल हैपन, because of rod this charge was distributed here, है ना, and once you are removing the rod, what will happen, this negative charge will get distributed uniformly because it's not bonded to anything, it will get uniformly distributed throughout the surface. So what will look like if when we will take ebonite rod away, what will happen, it will look something like this. So yes, this body has got charge now negative, है ना, and this ebonite rod has not lost any charge, it has not lost any charge, and this body has got charge by some amount in opposite sense. This was having positive charge, it is having negative. Okay, so this is your induction. Induction में क्या होगा, only conductors can be charged, because if it's not the conductor, then this charge distribution will not happen. And for induction method to work, charge separation should happen. Done. So induction can only be used to charge what kind of bodies? Conducting bodies. Contact not required. Both objects acquire opposite charge, types of charges. No loss of charge of the charging body. So this all happened. Any doubt, anyone? So to charge insulator, we will use what? Friction. To charge conductor, we will use what? Either conduction or induction. Anyone having any doubt? चलो doubt है तो बता दो. I will wait for another 1 minute. ठीक है? और समझ में आ रहा है तो भी if you can give thumbs up, please give. कुछ तो reaction दो so that I can understand you people are watching me. Okay, thank you. JMB Simoga, very good. One more I got. अच्छा हटा लिया. चलो. Okay, राजकोट, very good. चलो ठीक है, इंटरेक्शन होना चाहिए, है ना. दिस इज वेरी मच इम्पोर्टेंट. पता चलना चाहिए सामने से भी कुछ हो रहा है. चलो, व्हाट वी आर गोइंग टू रीड नेक्स्ट वी आर गोइंग टू रीड इलेक्ट्रिक फोर्स. इलेक्ट्रिक फोर्स में फर्स्ट वी विल लर्न कूलम्स लॉ. इट्स अ वेरी इजी थिंग्स. If you will stay connected now, things will feel very easy. And to make it more easier, you have to jump into questions. Okay? That we will do in the class also, and also in home you have to practice. So chalo, what we are going to read here, Coulomb's law. Permittivity, we will learn what it is, because this very much confuses students later. So we will make it clear here only. And then we will read principle of superposition that you must have studied in your wave waller thing also, but here it is for the vectors. So a bit different, we will learn, but easy. Coulomb's law kya hai? You all must have studied before, I guess, in 10th class. I don't remember exactly, but shayad padha hoga. So what is Coulomb's law? Coulomb talked about ki if there are 2 point charges, again very important is ki he talked about point charge, charges whose dimensions are negligible. Okay? So they are point charge. So if there are 2 point charges, suppose I have taken 2 positive charges, and if distance between these two is r, then Coulomb said that the force acting between these 2 charges will be directly proportional to, suppose one charge I'm taking as Q1, another as Q2. So force between these 2 charged particles will be directly proportional to product of their charges. Okay? And he also saw that in experiment, key force is inversely proportional to the radius ka square. Sorry, inversely proportional to distance between them ka square. Okay? So this is this. And this proportionality constant he written as K, and force became K Q1 Q2 by R square. Now what is this K? So this K is nothing but 1/4 pi epsilon naught. Now this epsilon naught is a new quantity for you people. Later I will explain. This is called permittivity in vacuum. I will explain what is permittivity, but for now epsilon naught is what it is. Permittivity in vacuum. So this is permittivity in vacuum. Done? Clear it? So if you can see here, force can be written as what? Again, if I'm going to break K, force can be written as 1/4 pi epsilon naught Q1 Q2 by R square. It means if my charge is kept in vacuum, if this is kept in vacuum, then force acting between these two charges will be equal to 1/4 pi epsilon naught Q1 Q2 by R square. If my force charges are not kept in vacuum, in some other media, suppose these two charges are kept in some other media जिसका permittivity value E है. Epsilon naught जब लगा हुआ है इसका मतलब क्या है? We are talking about permittivity in vacuum. If it is written as epsilon, it means we are talking about permittivity of any other media. ठीक है? So here force will become equal to what? 1/4 pi epsilon Q1 Q2 by R. Later we will understand what is the physical significance of this epsilon. क्योंकि अभी तक लग रहा होगा बस एक टर्म आ गया है, समझ में आ नहीं रहा कि ये टर्म है क्या. So we will understand that also. तो Coulomb's law में what things you have to keep in your head? It is applicable only for point charges. First thing and only thing you should keep in your head. ठीक है? तो याद रखना. Now Coulomb's law can be written in vector form also, क्योंकि Coulomb's law is talking about force. Force is a vector quantity. It will have direction. Done. So let's talk about the direction also. जैसे यहाँ पे I have taken two positive charges. So basically, force acting on one will be such that other will repel it. ठीक है? So if we have to write the force in term of vector, how we will write? ठीक है? तो vector तो आप लोगों ने बहुत पढ़ा होगा. So here I will go in a very simple way. Suppose the same Q1 charge I'm writing here and the Q2 charge I'm writing here. ठीक है? This one I have taken as origin 0 0. This is y axis. This is x axis. Position vector. You all must be aware of position vector. So position vector of charge Q1 is what? R1. Position vector of charge Q2 is what? This is my R2. So this is the position vector. Now, if I have to calculate force on 2 because of 1, so what I am going to calculate? Force on 2 because of 1. Notation wise, it will get written as this. Okay, so vector है तो मैंने चलो ऐसे लिख दिया F2 1. Force इसका मतलब क्या हुआ? Force acting on 2 because of 1. Done. Magnitude we have seen what it will be. Now let's see direction. So force on 2 we are calculating, right, on Q2. So Q1 will do what? Q1 will repel Q2 क्योंकि both has positive charge. Repel means separation between Q and Q2 को चलो लिख लेते हैं. So separation is this. Done. And on Q2 force will act in this direction. Force will act in this direction. Why? Because Q1 will repel Q2. Means Q1 will try to send Q2 away from it. So away means this direction. Towards होता तो इधर जाता arrow. ठीक है? So direction is this. Now what is this distance in term of vector? कोई बताएगा मुझे what is this distance in term of vector? In term of R1 and R2, what this distance will be? अगर मैं इसको vectorially दिखाऊं तो this distance vectorially can be written as what? Anyone? कोई बताएगा मुझे? बोलो. No? चलो ठीक है. So if you can see here clearly, अगर मैं यहाँ पे draw करके दिखाऊं, so this is my R1, this is my R2, and this is something, right? So this is nothing but R2 minus R1. How? So this is R2 now. R2 minus R1 अगर आप करोगे तो minus R1 ऐसा दिखेगा. This is R1. This is minus R1. So vector we can translate it parallelly. So अगर मैं बोलूं R2 माइनस R1, तो इसका मतलब क्या हुआ, वेक्टर R2 प्लस वेक्टर माइनस R1. So I am going to add two vectors, vector R2 plus vector minus R1. Now how we add two vectors? On the head of first, we put the tail of other. So head of R2 is where? Here. Tail of minus R1 is where? Here. Parallelly translate it, so it will look something like this. Now addition will look something like this. So this is nothing but this. Done. So this is what? This is your R21. Done. So what will be the value of force? Value of force we will write as K, where K is 1/4 pi epsilon naught, K into, क्या लिखोगे आप? Q1 Q2 divided by R21 vector का magnitude का square. Done. And what will be its direction? Its direction will be along this line. Done. So unit vector in the direction of vector R21. Unit vector we write as what? We put cap over it. So this is unit vector. Done. So this way we can write it. Just a standard thing to write force in a vectorial form. Done. Clear it? So this way we can do it. If you're getting confused somewhere after class, what you should do, you should take a copy and you should try understanding how R21 is this, R2 minus R. If you will do, you will get. Chalo, this is a question now for each one of you, and I'm going to give you 2 minutes for this. So take 2 minutes and solve it. Okay? I want answers. चलो क्वेश्चन पढ़ो. क्वेश्चन बहुत इजी है, मुझे समझाने की जरूरत है नहीं. This is very easy and do it. सबको करना है प्लीज. Everyone try. In case of any doubt, you can let me know through chat box. But everyone please try. Draw the things if needed and try calculating. Yes, yes, I got one, I guess. Yes, very good. Admin, what's the name? सही से यार नाम तो लिख दो. Others, please. Come on. Yes. JNB Rajkot. Very good. Come on, yaar. At least have that competitive spirit now. Nellore, Surendranagar, Simuka. Others, please come forward. Yes, Simuka. Done. सभी लोगों का करेक्ट आ रहा है. That's the good thing. Others, please participate. Hyderabad, Osmanabad. Yes. JB Mahe. There it is. Naam is beautiful. Ahmednagar. Come on, yeah. Come on, do it. Yes, Surendranagar. I got the answer. Thank you. चलो ठीक है, अब मैं करती हूँ. So what the question is, there are 2 point charges, A and B. They are point charges here actually. So A and B, take it as A, take it as B. I have exaggerated the shape, they are point, but I have drawn it to look so that you can look at it. है ना, point बनाऊंगी दिखेगा नहीं. Now one is having plus Q charge, another is having minus Q charge, and force between these two initially is given as what? F. So F must be equal to how much? K Q square by R square. And now F separation is something, R square le lo. Then now what is happening? If 25% charge of A 25% charge of A is getting transferred to B. So 25% charge of A means 25% charge of A means this much. So Q by 4 amount of charge is getting transferred to B. Now what will be the new charges on A and B? So A will have how much charge? Q minus Q by 4. Okay? And B will have how much charge? Minus Q plus Q by 4, because it's taking 25% charge of A. So this much. If you're going to calculate, this will be equal to 3Q by 4, and this will be also equal to 3Q by 4. Now new force will be how much? K 3Q by 4 ka square divided by how much? R square. So this is equal to F dash this one. KQ by R square into how much? 9 by 16. And KQ by R square is equal to what? F. So this is equal to 9F by 60. Okay? So this is 9F by 60. Chalo, done hai. Now what is permittivity that I want to make you understand. Suppose kar lo ki season is winter. Okay? And you are in North India where fog used to be so much. So suppose kar lo there are two persons are there, they are friends, and the day is quite foggy day, and they both are standing at certain distances. Let it call R. So if fog is, suppose fog is very thick, so these two persons, person A and B, won't be able to see each other. They won't be able to see each other properly. Now what happens? I'm talking about 6 a.m. in the morning. So at 6 a.m. in the morning, fog will be so much dense, they are not able to see each other. As sun will come up, what will happen? Yani ki as time will go up, 7 a.m. ho gaya, suppose 8 a.m. and so on, 10, 9, 10, done. So at 7 a.m. they will be able to see each other to some extent. 8 a.m. पे थोड़ा और देख पाएगा, at 9 a.m. थोड़ा और, 10 में हो सकता है पूरा ही clearly देख पाए. ठीक है? So permittivity is same as this. Means if there are two charges in a media, okay, and if these two charges are able to clearly see each other, then if they are able to clearly see each other, force, जैसे दो आदमी अगर एक दूसरे को देख पा रहा है तो इंटरेक्शन से ही होगा. Similarly, if these two charges are able to see each other properly, they will interact to larger extent, so force acting will be more. Okay, so they are able to see each other clearly means media is what? Vacuum. So in vacuum, permittivity is what? Permittivity is very much this charge will be able to see this charge more. ठीक है? So वैक्यूम का केस ये है, जैसे जैसे आप मीडिया चेंज करोगे, चार्जेस won't be able to see each other properly. अब इसका permittivity के मैग्नीट्यूड से क्या रिलेशन है? Let's see that now. So physically you can imagine permittivity like this. अब चलो force पे चलते हैं. So force is written as what? 1/4 pi epsilon Q1 Q2 by R square. So let's focus on permittivity only. So force is inversely proportional to permittivity. If permittivity is more, it means force will be what? Less. So if there is more fog, it means permittivity value is what? It is high. And that is why force will be less. Done? So in case of vacuum, permittivity is how much? Epsilon naught, and epsilon naught value is very much less. And that is why in case of vacuum, you will get the highest amount of force between these two charges. Okay? As you will increase the media, what will happen? Value of epsilon will increase. And if that is going to increase, force value will decrease. So this is the role of permittivity in force acting between two charges at certain separation. Done. So this is done. I hope it is clear. Now find the dimension of permittivity. This is your question. Do it again. Take some 1 or 2 minutes and do it. Dimension of permittivity you have to calculate. क्योंकि क्वेश्चन डायमेंशन का भी होता है. Even in G advanced match the column type questions में you will get dimension wala thing. So you should be very much aware of dimension of each and everything that you are encountering while reading physics. So calculating permittivity is very important. Do it now. Dimension calculate karo aap and let me know. Come on everyone, कैसे निकालते हैं? क्या लिखोगे आप? Permittivity का dimension निकालना है ना? So simply write force equal to what? 1/4 pi epsilon q1 q2 by r square. So write the dimension of force, write the dimension of charges. Okay. JNB catch. Okay. N is for what here? Terms are missing, I guess. You need to recheck it. Because first of all, you will be getting 4 variables, okay, like length, mass, time, and current. Yes, it seems like correct. Yes, JNB कक्ष पढ़ते हैं उसको शायद. चलो, race people, come ahead, please. Everyone, come on. And yes, instruction for those people who are unable to write even the dimension of force. Please learn it. Try learning it. Even if you don't know now, try learning it. Force को हम कैसे लिखते हैं? Mass into acceleration. Acceleration is what? Velocity by time. Velocity means what? Distance by time. So its dimension is equal to how much? Length t minus 1. Acceleration is what? Velocity by time. So this will be how much? LT minus 1 by t. So this will be equal to LT minus 2. Now mass into acceleration. Yani ki force ka dimension will be equal to what? Now you can easily write now MLT minus 2. Why I'm telling these things? Because recently when I visited one of the JMB and their students were preparing for what? G mains, and just exam was some 1 or 2 months ahead. 1 month ahead, I must say. And they were not aware of these things also. Done. So you should not reach to that situation. Now you should start learning, है ना? So this is this. Now epsilon का dimension हमें नहीं पता, तो आप इसका dimension ऐसे करके लिख लो. इसी को पता करना है. Now what's the dimension of charge? Charge, not a fundamental quantity. Current, yes. So current is written as what? Charge by time. So current का dimension we write as A, and this is what? Q. Q का डायमेंशन ऐसे लिख लो, टाइम का डायमेंशन t. सो क्यू का डायमेंशन क्या हो जाएगा, ए टी। सो यहाँ पे आप लिख लो ए स्क्वायर टी स्क्वायर। नाउ यू जस्ट राइट व्हाट विल बी द डायमेंशन ऑफ व्हाट एप्सिलॉन। सो डायमेंशन ऑफ एप्सिलॉन विल बी इक्वल टू हाउ मच, m minus 1 l minus 1 t का 4 a का स्क्वायर। so I guess one of you got this answer I guess। l में कुछ प्रॉब्लम था, नहीं r को मैंने मिस कर दिया यहाँ पे r का स्क्वायर भी है ना, सो यहाँ पे l का स्क्वायर होगा। अब l का स्क्वायर होगा तो यहाँ पे 3 पावर जाएगा, ठीक है। तो चलो दिस विल बी योर व्हाट आंसर। डन है, क्लियर है सबको। सो कूलम्स लॉ इज डन, परमिटिविटी इज डन, वी हैव अंडरस्टूड इट आल्सो। नाउ सुपरपोजिशन प्रिंसिपल, दिस इज वेरी इजी। जैसे अभी अभी हमने क्या पढ़ा कि व्हाट will be forces between two charges. So if there are two charges q1 and q2 separated by distance r, then force on any one charge, let's say force on second charge because of one was written as what, k q1 q2 by r square magnitude wise, ठीक है। If I put the direction here, so that will be equal to r21 this, यानी कि along this direction। Done। So if we have more than two charges, how we will calculate the force? For that we learn superposition principle. So इसमें कुछ करना नहीं है, this is nothing अलग सा thing, ठीक है। Same as whatever we have studied till now. So suppose कर लो कि I am saying there are 3 charges, Q1 यहाँ है and Q2 is somewhere here and Q3 is somewhere here. So if we have to calculate, suppose now force on Q1 because of these two charges, जैसे force on Q1 suppose निकालना है मुझे, so on Q1 which charges will apply force, Q2 will apply force, Q3 will apply force, right? Now let's see कि Q1 on force on 1 I am calculating. So force on 1 will be because of what, force on 1 will be because of second charge, so F21 plus force on 1 will get applied because of Q3, so that I'm writing as F31, force on 1 because of 3, sorry notation उल्टा ले लिया है मैंने, force on 1 because of 2 लिखना है ना मुझे, तो यहाँ पे आप लिखो force on 1 because of 2 and force on 1 because of 3। so force acting on first charge will be because of charge 2 and charge 3. So this is superposition, done। And force acting on 1 because of 2 will not get affected by charge third present in the environment. So F12 को अभी भी हम लोग क्या लिख सकते हैं, we can easily, if this distance is R12, force on 1 because of 2 will act in this direction ना, इस direction को मैं R12 बुला रही हूँ। So F12 can be easily written as K Q1 Q2 by R1 2 का square. So it is not getting affected by third charge present, and that is basically the superposition, ठीक है। कि charge acting, if there are more than 2 charges, then charge acting on 1 because of 2 will not get affected by third or fourth or fifth charge present in the environment. We can individually write forces independent, ठीक है। So that's your superposition, done, clear है। So in the next class I will be writing what, vectorial form of it, that's not required much but still I will be writing that here, done है। और थोड़ा सा superposition principle से we will be doing question rigorously, so in the next class I will let you do some 2 or 3 questions from this thing। Vectors application will be largely there, so do revise vectors please, those who are not aware of these things, ठीक है। So in the next class we will read first, carry ahead this superposition वाला thing, और उसके बाद we will study electric field and all, ठीक है। तो चलो कल मिलते हैं, और कल के क्लास में I will be giving you homework also, क्योंकि आज की क्लास में उतना कुछ डीप में हमने पढ़ा नहीं, so that we can do more and more question, but yes after tomorrow's class I will be giving you questions to do, ठीक है। So any doubt anyone? Still 1 minute left, if anyone has any doubt let me know please। किसी को डाउट है, नहीं है ना, है तो बता दो। और चिल करो थोड़ा, डोंट टेक मच बर्डन एंड मच प्रेशर, ठीक है। अभी एक क्लास होगी तुम लोगों की, है ना, तो थोड़ा सा 5 मिनट के लिए बाहर जाओ, चिल करके आओ, रिलैक्स करो खुद को, ठीक है। आई वॉन्ट किल योर टाइम। तो लेट्स मीट टुमारो अगेन। स्टे हैप्पी, पॉजिटिव, कीप ऑन वर्किंग एंड डोंट टेक अ स्ट्रेस, एंजॉय, ठीक है। बाय बाय, टेक केयर।